All right, looking at our fourth example of Newton's third law in interaction diagrams. Consider a complicated examples of two twins, George and Fred, pulling each other with a rope like tug of war. George and Fred have the same mass and the same shoes. They are both at rest on rough concrete. Draw an interaction diagram. You can ignore the rope as a distinct object. Okay, so let's start over here with George. Think about what forces might be acting on George. Okay, well, first of all, George is standing on the ground, which means that he's interacting with the earth. And so George is going to be interacting with the earth in two ways. One, through the force of gravity. The other, through a normal force. And then George is also being pulled by Fred through this rope. So George is going to be interacting with Fred through tension, right, in this rope. Is George also going to be pulled by Fred gravitationally? Sure, because they both have mass, but that's an extremely, extremely weak force, so I'm going to include it, but I'm only going to include it as a dashed line to say it's present, but we're going to ignore it. All right, let's go to the other guy, Fred. Oh, you know what? And there's one more I just thought about, right? And I underlined it up here, right? Rough concrete. So what's preventing George from slipping in this tug of war? Well, he's gripping the earth through friction. So there is a frictional force in addition that's acting on George. So it's a third interaction with him and the earth. I'm going to draw it like way out here. Friction. And by the way, if you know the different types of friction, static friction is friction when there's no slipping. It's the friction of gripping. Kinetic friction is when you're sliding. So assuming that George is not sliding, that he's actually gripping the ground, we would call this static friction. All right, let's go now to focusing on Fred. And I'm going to change my color just to help us stay organized. Fred has all the same forces acting on him, right? He's interacting with the earth through a normal force, through gravity, and he's interacting with the earth through static friction. Okay, he's also interacting with George through tension, but I've already got that. And he's also interacting with George through gravity, but I've already got that. Okay. All right. And then the only other object I haven't considered is the earth, but as like a separate object. But I've got the earth covered, right? Pretend that you're the earth. You've got George standing on you. You've got Fred standing on you. You can feel their weights. You can feel the friction from their shoes. And so the earth is covered in our diagram. All right, as normal, it's very helpful to count the number of lines coming out. So George has 4 lines coming out, and George has 4 forces acting on him. Fred has 4 lines coming out. Fred is going to have 4 forces acting on him. The earth has 6 lines coming out, and will have 6 forces acting on it. So let's see if we can stay organized here. Starting with George. George has tension, normal force, gravity, and static friction. Okay, so let's start with the easy ones. George will be pulled down by a force of gravity from the earth. George will be supported by a normal force from the earth. George is going to be pulled with this tension, and here it is, right? Tension from Fred. But which way is that tension going to act? Well, imagine you're George over here, and you've got this rope. Fred is pulling George towards himself, right? George is going to get pulled this way from that rope. So we want a rightward force of tension on George, and that's coming from Fred. And as George is pulled to the right by the rope, well, what resists that pull? Why isn't George pulled to the right? Because his shoes are gripping the earth. So his shoes must be holding him back. There's that static friction, right? And that's from the Earth. Okay, and I can see that here again, right? If I follow that line, static friction is coming from the Earth. I see it right there in the picture. All right, I said it in the interaction diagram that George had 4 forces, and I've got all 4 on George's free body diagram, so George is good. Let's move to Fred. Fred has the same stuff going on, okay? Fred's got a normal force from the Earth. Fred has gravity from the Earth. Fred is being now pulled to the left by George through tension. And Fred's shoes are preventing him from sliding left. So there's that static friction. And what's the source of that? The Earth. Okay, so we're done with Fred. We've got Fred's 4 forces. Now the Earth has 6 forces. Okay, so it's going to be helpful to follow the lines in the interaction diagram. I'm going to go with red. Okay, let's start here. The Earth is going to interact with George through gravity here and the normal force. So let's try those. Gravity and the normal force. The Earth will be pulled upwards by gravity with George. The Earth will be pushed downward by the normal force from George, right? George is standing on the Earth. So the Earth is going to feel that downward push. Okay? And then the Earth is also experiencing right here, right? Static friction from George. So the direction is a little bit tricky. Imagine that you are the Earth. And again, it helps to come back up here. So imagine you're the Earth. George is being pulled this way by Fred. And so if you're the Earth, you would feel George sliding to the right on your surface, right? Fred is pulling George to the right. And so you would feel a pull from George's feet scraping across the surface of the Earth right here. George's feet also are going to go this way. So we've got to the right static friction. And that is now from George. If you want to double check that, if you're not convinced, remember the equal and opposite rule. So this would have a force pair, right? Where's the force pair? Where's the equal and opposite force? So this is the force of static friction on the Earth from George. The pair would be the force of static friction on George from the Earth. And that's right here. That's the pair. So they are, in fact, opposite directions. So we got the direction right. Okay, and then the Earth has 3 forces from Fred. Okay? Normal force, gravity, and static friction from Fred. So let's add those. And I'm actually going to use a different color. So Earth is being pulled to the left by static friction from Fred. The Earth is being pushed upwards by a force of gravity from Fred. Fred's also right above the Earth. And as Fred is above the Earth feels Fred pushing down on it. A normal force from Fred. And now I have 6 forces on the Earth, which match my 6 forces in the interaction diagram. That is about as hard as it gets, folks. That was an example of 3 interacting objects through multiple forces. So this is Newton's third law, interaction diagrams, and the free body diagrams that they help us draw.